Hello students, today we are going to take up one more transportation problem and we are going to find out its initial basic feasible solution by applying WAM method, that is Vogel's approximation method. So first of all, in this case what we have to find out, whether this transportation problem is balanced or not. So we are going to calculate supply and demand here. Now see here, we have 7 plus 9 plus 18 and it sums to 34. So we have a supply of 34 units. Fine, and then we are going to calculate demand. It is 5 plus 8 is 13, 13 plus 7 is 20, and 20 plus 14 is 34, and hence we say this is a balanced transportation problem, and hence we can apply VAM method. So for this, what we are going to do, we are going to calculate the penalties first for both rows as well as columns. So we will start with the P1. How we calculate this penalty? This penalty cost we calculate by difference between the two smallest and the next smallest cost in each row and column. Now if we talk about here, we have first smallest is 10 and the second smallest is 19, and hence the difference is 9. Am I right? Then in the second one, if we see, the first smallest is 30 and the second smallest is 40, and hence the difference is how much? It is 10. Now if we see here is 20, no, so 8 and 20, and hence the difference is 12, that is 20 minus 8. Now coming to here, we see here we have 20, 10 and 20. These are the two least cells. So 20 minus 10 is 10. Fine. Then we come to here. We have 40 and 50. 50 minus 40 is again 10. We have here, it is 8 and 30. Fine. And hence the difference is how much? It is 22. Now here we have 19 and 40. 19 and 40. If we see 40 minus 19, 40 minus 40 minus 19, the difference is 21. Fine. Now what is the next step here? The next step here is we have to find out the highest penalty. Highest penalty we have to find out, and then we have to see the lowest cell here. Now if we see here, the highest cost here, the highest penalty here is, it is 21, and hence we are going to find the lowest cell in this column. It is 19. After this, what we are going to do, we are going to see what maximum can we allocate here. We have a demand of 5 units and supply of 7 units. That means a maximum of 5 units we can allocate here, and here we have 0, and here 2 units are left, and we are going to cancel this row. Fine, we are going to cancel this one. Then we are going to calculate P2. Now see here, the difference, the two lowest cells are 10 and 30, and the difference is how much? We have here 10, the first lowest is 10 and the second one is 30, that is 30 minus 10 is 20, and here if we see, we have here 30 and 40, and the difference is 10, and if we come here, we have 88 and 20, and the difference is 12, Now coming to this one, we have again same, this will not change, this will again not change, it will be 10, this will again not change, 20, and here it is nothing. So the highest penalty that we have here now is 22. 22 is the cell with highest penalty. Now in this column, we are going to find out the lowest cost cell. It is 8, and to this 8, how much we can allocate? Maximum 8 units. So let us allocate it. How much? We are going to allocate it 8, and here demand comes to 0, and here it comes to 10. Fine. So we are going to delete this row here, now this column. After that we are going to calculate P3. We have here 50 and 10, the difference is 40. The difference is 40. Here we have 60 and 40, the difference is 20. Here we have 70 and 20, the difference is 50. Fine. Here it will not change, it's 10 as we have. This one is how much? This is again 10, and here we have nothing, and here again nothing. Now if we see the highest penalty, here we have 50, which is the highest penalty, and hence we are going to see the lowest cell is 20. To this 20 we can allocate maximum of 10 units, because we have a supply of 10 and the demand is of 14. So we are going to reduce it to 0, the supply, and then here 4 units are left. Fine. So we are going to delete this row. We are going to delete this row here. Fine. After that, coming to P4, right? P4 again. How much is the difference here? Is 40. This is 40. How much is the difference here? This is 20. How much is the difference here? No difference. Then if we come here, this is 60 and 10. The difference is 50. And if we come here, the difference is 50 minus 40 is how much? It is 10. Here we have the highest penalty, it is 50. And we are going to allocate to the lowest cell here. To the lowest cell here is, which one is 10. To this 10 there is a supply of 2 units and a demand of 4 units. That is maximum we can allocate here is 2. This reduces to 0 and this comes to 2, and hence we are going to delete this row. We are going to delete this row here. Fine. Now we have last 2 cells here, this 40 and 60. If we see the lowest cell here is 40, we have a demand of 7 units here and supply of 9 units. The maximum we can allocate here is 7, and hence the demand comes to 0 and supply remains 2 here. So what we are going to do, we are going to delete this cell. Now we have only one here, that is 60. 2 supply is left and 2 is the demand. So this is going to come to 0 and this again going to come to 0, and hence our supply and demand is exhausted here. Supply and demand is exhausted here. Now if we see here, the number of occupied cells here is 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 and 6. So we have here 6 occupied cells, and the size of this matrix is m plus n minus 1, that is 4 plus 3 minus 1. 4 plus 3 is 7, 7 minus 1 is 6, and hence the initial solution here is a non-degenerate solution, and hence we can say an optimal solution can be obtained. Now we are going to calculate the total transportation cost of this matrix. So how are we going to calculate that? So let us calculate the total transportation cost for this cell. The total transportation cost for this cell can be calculated by like this. Total transportation cost we are going to calculate, that is equal to 5 into 19, 5 into 19 plus then we have 2 into 10, 2 into 10 plus we have 40 into 7, 40 into 7 plus we have 60 into 2, 60 into 2 plus 8 into 8, 8 into 8 plus 20 into 10. Fine. Now if we see 5 into 19 is 95 plus 2 into 10 is 20 plus 7 into 40. 7 into 40 is 280, plus 16 into 2 is 120, plus 8 into 8 is 64, plus 20 into 10 is 200, and if we sum it up, it comes to 779, and hence 779 is the cost for this. Now my dear students, I am going to apply a Modi method to obtain the optimal solution of the same problem that I am going to continue in the next video. Thank you so much for watching this video. Please watch my next video on the concept of Modi, when I am going to apply that concept to this transportation problem to find out the optimal solution. Thank you so much.